One of the most important things of not just web applications, but applications in general, is handling user input, because that is how we make our application do what it is supposed to do. If we are writing a website for a storefront, we need to handle user input so that we can display the correct products. If we are writing a blog engine, we need to handle user input so that we display the appropriate blog entries. And things go on. In this lesson, we are going to talk about GET requests, because these are the most common requests that are made to any web application. Just about anything that you do by default within the browser is going to issue a GET request. So if you type something into the address bar, press enter, that's going to issue a GET request. And a GET request is really just us requesting to retrieve information. There's no side effects or anything like that. We just want information from the web server. So we just made a request to php.net, and the server responded with what we see here. If we click on any one of these links, like documentation, that's going to issue another GET request, and then the server is going to respond with what we see on the screen. So GET requests on the surface are very simple. And really, they are simple. It's just that since they involve user input, we have to be very, very careful. Because the first rule, and really the only rule about user input, is to not trust it. And it doesn't matter if it's a web application or a conventional application running on the desktop. Any information that we do not control, we must assume is malicious, because that is the only way that we are going to protect ourselves and our application from any type of malicious intent. So, the primary way that we get information from a GET request is from what's called the query string. Let's go to google.com and let's do a quick little search for PHP. If you look at the address bar, you have www.google.com, then you have /search, that's the resource that we made a request to, but then there's this question mark. Well, everything after the question mark is what's called the query string. It contains a series of key value pairs that the web application is going to do something with. So the source is HP, I don't really know what that is, but the Q equals PHP. So Google's web service is looking for this Q query parameter, and it's going to take that value and then perform a search on that value. So that is how Google's web servers know what to search for. The request being sent to their servers has this Q in the query string, and it is set to PHP. So, of course, our application doesn't look for any of these query parameters by default. We have to program that in. Of course, it's there available for us if we want to access it, but we have to write the code that's going to look for those things and do something with those things in order for our application to react to those things. So let's say that we are going to write a store. And in order to display an individual product, we need to know the ID, or the way that we identify a particular product. And for the sake of simplicity, we are going to have a query parameter just called ID. So let's go to the browser. Let's make a request for this. By the way, I'm in folder 3.1. The file is get-input, and we are going to add a query string here. So we have a question mark followed by ID, because that is the query parameter that we are going to look for to get what product to display. Or I'll tell you this, let's do product ID. That way, it's a little bit more clear as to what we're looking for, and then we can just type something. Let's just have the number 10. Now, if we press enter, we made a request to our PHP file with that query string, but of course, our application isn't looking for that. So let's go back to our file, and we are going to create a variable called product ID, and we get that value with what's called a super global, and I'll show you why it's a super global here in a moment. But it is _get, and this is an array that contains all of the keys in our query string. Our key is product ID, And that is going to give us our product ID. So we can output that down here. So we will use the shorthand syntax to output product ID. And there we go. So let's go back to the browser. Let's refresh the page and undefined index product ID. And that's why I used camel casing. Let me get this on screen. I used camel casing whenever I specified the key with the get superglobal. And in the query string, it's all lowercase. So it is case sensitive. What you type in the query string has to absolutely match what you type in your code. So let's go back. Let's change that to make this all lowercase. And now we will refresh the page and we see the value of 10 there. Now we can change this to whatever. If we had a product ID of just some letters, a dash, number, and some more letters, we are going to see that absolute value there. But let's also do this. Instead of a product ID, let's say that we want to display all of the products of a given category, and we want to limit the amount that we show on screen. So we'll have category equals, and then whatever category ID, let's go with 10 again. And then for a second query parameter, we use an ampersand, and then limit equals, let's say that we only want to show 2. So, well, let's make that request. First of all, we get a notice here because we are trying to find product ID inside of our get superglobal and it doesn't exist. So we're going to have to handle that later on. But let's do this. We're going to get our category and then we want to get the limit. So we'll just call these variables category and limit. We will use our get superglobal and get those values. So now we can do this. We will say showing category and then our category, and let's have a period, limit, and then we will output our limit as well. And when we go to the browser, we see showing category 10, limit 2. And of course, these values are going to change as we change the values in our query string. So if we want category 1, limit 30, then that is what is reflected here in the document. So I said that I would show you why these are called superglobals. So let's copy these 2 lines, but let's first of all initialize these variables as empty strings so that we have them created. And then we're going to write a function that is going to set these 2 variables. So let's just call this set values. And these are global variables. So we need to say global category and limit, and then we're going to set those. So now let's call set values, and we will see the same results. Category 1, limit 30. Now notice though, that whenever we specified the global variables that we wanted to use, we didn't specify get. We just specified category and limit. So that's why these are called superglobals. They are accessible throughout our application. We don't have to opt in to use them. They are just there for us to use all of the time. So that is why they are called superglobals. Okay, so we have established that whatever is being given to us through the URL for a GET request is the user input, and we can do something with that information. But now watch this. I am going to put a script here, JavaScript. We are going to alert hello world, actually, hello cross-site scripting. So XSS, and we need to close that script element. Now Chrome is not going to allow us to do this. If we make that request, it says that Chrome detected unusual code, and it's just not going to let us. Let's go to Edge, and let's make that same request. So once again, I have specified HTML as the limit, so that if the user wanted to inject their own JavaScript into this page, they could. As you can see right here, we see an alert box saying hello XSS. And that is a huge, huge security concern. And this is why I say you should never trust user input, because anybody can come up here and they can make a request They can pass in whatever information that they want, and if we don't take the steps to protect our application, then our application is going to be the launching pad for attacks. And don't think that your application is small enough that it can be ignored. You need to protect yourself. So anything that comes in via user input needs to be validated. And PHP gives us several tools for doing that. So here we have category and we have limit. And we know that these two things are numeric values, and they aren't just numeric, they are integers. That means that they are whole numbers. So we have the ability to perform validation on these inputs so that we can make sure that they are integers, and if they're not, then we can say, hey, nope, not going to do it. So we are going to call a function called filter_input. And this accepts several arguments. The first is the type of input that we want to validate. So that means it's either a GET request, it's a POST request, we are dealing with stuff from a cookie, or a server variable, or things like that. In this case, it is a GET request. So we say input_get. Then we specify the name of the variable that we want to validate. In this case, that is category. And then we have the filter that we want to use to validate this input. And in this case, it's called filter validate int. It's going to ensure that whatever is passed in through the category query parameter is an int. If it is not an integer, it is going to return false. Otherwise, it is the actual value that we wanted to work with. And we'll just copy and paste this for limit as well. We will change the variable name to limit. Now notice that there are no $signs. That is just the name of the variable itself. So now we can do a check. If category is equal to false, or if limit is equal to false, then we can do something that's called die. Die in PHP means that it stops completely. No more processing is done with the request. So let's go back to Edge if that is still open, and let's make a request for our page that is using the cross-site scripting attack. We press enter, and it looks like nothing happens. Now we still have our header, and let's look at the source, because this is going to tell us what is going on. Well, it's not really going to tell us what's going on. It's going to show us where the PHP page stopped processing. So when it finally loads, if it does load, then we should see there. It ends at the closing tag of nav. Now, the reason why we see that is if we go back and look at our code, well, we have included header, and of course we have required one. So all of this code has executed, but now we have gotten to where we die because the limit is invalid input. So nothing else is going to execute. So it stopped right here, and we see exactly what we should be seeing, at least as far as our code is concerned. And if we go and look at this in Chrome, we can pass anything that is not an integer to limit, and we are going to essentially see the same thing. And once again, if we view the source code, same thing. It ends at the closing tag of nav. But we could also approach this in a different way. We could say that, okay, if category or if limit are invalid, then we can still display the category with a limit. We just had to set some default values. So we can do this. We'll keep this, but we need to break this up into two if statements. So we'll have an if statement for category. If it's false, then we will set a default value for category. So let's go ahead and do that. We'll set it to, I guess, 1. And then for limit, we can set the default limit to 10. And then our code is still going to work. We have still ignored the user input, and that's really the most important thing. The most important thing is that we have caught invalid input and we are not using that input. Instead, we are replacing it with our own. So now, even though we have invalid input, we still have some action going on. And if we change the category to, let's say category 100. We can see that category 100 is still there, but our limit is still 10. Now, if we omit limit, we are still going to see limit of 10. So in this case, we don't have to check to see if we have a limit or a category. The filter input is going to handle all of that for us. If it's there, it's going to validate it, and if it is valid, we get the value. If it is there and it's not invalid, we get false. If it's not there, we get false. Now, there are many filters that we can use, and I'm going to put a link to the PHP documentation that tells you all of the built-in filters. There are validation filters, which is what we used. There are sanitize filters, so that you can use them to strip out anything that you might not need. Like, for example, if you need an email address, it'll strip out everything that is not an appropriate character for an email. There's other filters and then filter flags. So this is very useful. The more code you write and the more filters you use, the more you will have them memorized. And you will memorize some of them because there are some that you will use regularly.